Okay, so today we're going to learn how to use trigonometry to find a missing side or an unknown side. So our learning intention is we're going to learn the skills and the process of how to use trigonometry to find a missing side. We're successful if we actually can correctly decide which trigonometric ratios to use, correctly apply the trigonometric ratio, and produce the correct solution. Okay, so we'll do. All right. Here we're given a right angle triangle. We're given an angle and we're given two sides. One of them is known and one of them is not known. Last lesson we went through the acronym of SOHCAHTOA, and that was our trigonometric ratio. So we're going to use this to figure out which function or which kind of puzzle breaker we're going to use to find out the missing side. So the first thing we should do is label our sides. So we've got, this is our hypotenuse. Yeah, because opposite the right angle. Here's the angle that the question is giving you. There's nothing written on the adjacent side, so I'm not going to bother writing A here, and I'm going to write O here, because this side is the opposite from my angle. I may not have a measurement, but I definitely have a letter here. So I've got X. So I don't know what it is, but I've got something here. So really I have an O and a H. So I look at my SOHCAHTOA and I go, well, where do I see O and H together? And it's really here in the first part. Here is AH and here is OA. So here I have got OH, so I've got the I've got the sine. So I actually have this sine theta is equal to the opposite side over the hypotenuse. Okay, so now I'm going to just plug in what I do know. I know what this theta is, a Greek letter that usually we represent that to mean angle in mathematics. So I know what that is. It's 30 degrees. So I'm going to write sine 30. My opposite is my letter X, and my hypotenuse is 5. Okay, and all of a sudden now we have this algebraic expression. And using our algebraic skills, we can realize we can get rid of this divide by 5 by multiplying both sides by 5. And if I did that, if I times this by 5 and times that by 5, what ends up happening, I'll get this 5 sine 30 equals X. Now this is a number which I can use my calculator to produce the solution. So if I get my calculator out and I press 5, and there's my button sine, so just above the open brackets, sine 30, close my brackets and press equals. Oh, sorry. I'm in my computer set up in the wrong way. Okay. I get 2.5. So X equals 2.5. And because it's a measurement, it's in centimeters. Okay. So let's look at the next example. All right. Let's label the parts. I have my hypotenuse. Here is my angle. And I have something I don't know on my adjacent. So I have A and H. So look at my SOHCAHTOA, and I know that I've got a cosine. So if I write cos theta equals the adjacent over the hypotenuse, so that's the formula, and then I plug in what I know. So my degree or my angle is 31 degrees, 12 minutes. My adjacent is alpha, and my hypotenuse is 3. Okay. To get rid of this fraction, I multiply both sides by 3, which means that this comes up here. So I get 3 cos 31 degrees and 12 minutes equals alpha. Use my calculator to figure what this is. I get 3 cos is next to the sine, so it's just Yep, 31 degrees and 12 minutes. And close my brackets. So I must have my degree sign and I must have my minute sign. If I exclude that, I'll get a math error or syntax error. Okay, I need to put in my my symbol for my minutes. Okay, so I'm going to round this to 1 decimal place. So it's going to be 2.6. It was 2.6 centimeters, 1 dp. Okay. All right. Last example from this page. All right. So we have this angle here. I don't have my hypotenuse. I don't have another side that's been marked. So let's say we're trying to find this side. We'll call that x. Yep, and we may as well do 2. We'll find x and y. Yep. Okay. Finding x first. I've got my opposite side, and I have my adjacent side to my angle. So I have tan. So I could write tan theta equals opposite over adjacent. Plugging what I know, it's 21 degrees and 12 minutes. My opposite is x and my adjacent is 2. Multiply both sides of the equation by 2 to get rid of the fraction. That gives me x. So if I plug that in, x is worth 2 lots of tan 21 degrees and 12 minutes. Close brackets. So x is 0.2 decimal places, 7.8 centimeters, because it's a measurement. If I wanted to find y, I would have the adjacent and the hypotenuse. That's cosine. So cos theta equals adjacent over hypotenuse. So cos is 21 degrees and 12 minutes. My adjacent is 2. My hypotenuse is y. To get rid of that y, I would have to multiply both sides by y. So it ends up getting y cos 21 degrees 12 minutes equals 2. Now, this is just a number. So if I want to get, like, you can think of like this being 3y equals 2. Yeah. To get rid of that 3, I'll divide by 3. So I can actually divide y cos 21 degrees and 12 minutes by cos 21 degrees and 12 minutes. Okay. So it gives me y equals 2 lots of cos 21 degrees and 12 minutes. That's a number that we can find using our calculator. So we've got 2 over cos 21 degrees and 12 minutes, and close the bracket. So I've closed and I've put both symbols, and I get 2.15 centimeters to dp. Okay. All right. Some more examples. Let's look at these ones. So I've taken off the acronym. I have my H here. I have my adjacent to my angle. So I have so I must have cos. So cos theta equals adjacent over hypotenuse. So that's 31 degrees. My adjacent is 2, and my hypotenuse is the letter A. Very similar to what we did before. We multiply both sides by A. And then we divide by cos 31. Using our calculator, 2 lots of cos 31 degrees. If I don't close the bracket, I get a syntax error. So just go back and close it. So I get 2.33. They're in meters to dp. Okay. Here we have Okay, here we have the hypotenuse, and we have the opposite. So OH we have sine. So sine theta equals O over H. The degree is 25. The opposite's 15 millimeters, and the H is B. So when the unknown's on the denominator, what I can do is just swap them around. Which is swapping around means basically I'm multiplying both sides by B, and then I'm going to divide both sides by sine 25. Using the calculator, I've got 15 over sine 25 degrees. And that gives me 35.49 millimeters 2dp. Okay, last example. So I have the opposite to the angle I'm given and the adjacent side to the angle I'm given. So that's tan. So tan theta is O over A. The degree is 21 degrees and 15 minutes. My opposite is 7, and my adjacent is letter C. I can multiply both sides by C, and then divide by tan 21 degrees and 15 minutes, which gives me, I plug that into calculator, make sure I close the brackets, I get 18 meters to the nearest whole nearest meter. Okay, and that's how we use the trigonometric ratios to find out the missing lengths. Thank you.